With a good afternoon once again. Let me start the lecture. First of all, we should know how much we have learned yet. We have discussed the basic organization of computer. We have learned what computer exactly is, what are its different applications, what are its basic characteristics, what is its composition like hardware, software, etc., firmware too. Then every devices we have discussed in detail, whether it is hardware like input device, output device, IO devices. We have discussed software, whether it is application software or system software. Now it is the time to know how two or more computer interacts together, because if we don't learn networking, we will be away from the present technology. No task can be done on standalone computers. They can interact with each other for the purpose of sharing information, for the purpose of sharing data, for the purpose of sharing different resources to each other. So the agenda for today's lecture is data communication and computer network. I'll be starting with data communication first. And then computer network. Though both these terms can be used interchangeably, but there is a difference between computer network and data communication. So let's know first what we mean by data communication. Data communication is nothing but the exchange of data, exchange of information between two or more devices, two or more nodes, via using some wired or wireless transmission media. There are few characteristics for any data communication that is to be taken, like whenever communication starts between two nodes, that means when we are sending some information from one computer to another, then there must be ensured delivery. Delivery of the data must be ensured. Then another characteristic of any data communication is whatever information is being sent, it must accurately be sent. That is, an accuracy of data must be maintained, accuracy of message must be maintained. It should not be changed, it should not be accepted by anybody but for the receiver who is intended for. And third characteristic is that whenever information is being sent, communication is being taken place, it should reach to its destination timely. Though we are aware that the component of any communication could be, number one, we must be having some information, some data that is supposed to be sent, that is, sender of information must be there, receiver must be there, then some communication is supposed to be established. That means they must be connected to each other via some transmission media. There must be some information or some message that is supposed to be sent. And last basic component of any data communication or any data network is there must be certain principles, rules, protocols on which the connection is to be established, the communication is to be taken place. Before sending some information from node A to node B, we should know in how many ways transmission can be taken away, or safely I say, what are the different transmission modes. By transmission mode, I mean the manner in which communication between two or more devices takes place. If I say this is node A, which is supposed to interact with node B, then one type of transmission mode is simplex mode. The transmission mode is said to be simplex if the transmission is only in one direction. That means node A can send some information to node B, but vice versa is not true. B cannot send the information to A. Such type of transmission is known as transmission which is taken place in simplex mode, right? Another mode could be half duplex, By half duplex I mean the data, the information, the transmission can be in both the direction. Means A can also send some information to B and B can send some information to A. But the problem is, if A is sending some information to A, in the meantime B cannot send any information to A. So this can be taken in this manner. If A is sending some information to B, then it will not work. If B is sending some information to A, that means A will not work. So transmission at a time can be taken place only. At a time only one transmission is possible. Example for this could be police radio or walkie-talkie. Whereas in simplex mode transmission, example for this transmission mode could be television, broadcasting on television, right? Third is full duplex. Full duplex transmission means that A and B can send the information and the transmission can take place simultaneously. Means A can also send some data or information to B, B can also send some information to A. So transmission can take place simultaneously at a time. Example could be telephone, conversation on telephone. After knowing little about what we mean by data communication, now let's learn what is computer network. It can be learned as the interconnection, the connection, communication of two computers. But see, in communication we say that it is exchange of information. In network we say that it is interconnection of two or more devices. So application of network is communication and the physical layout of communication is computer network. Both can be learned interchangeably, but there is a difference because one is application, another one is its abstract form. Write down what is computer network. Computer network is a group of interconnected computer for the purpose of communication. This is computer network which allows communication between two or more devices. Transmission mode we have discussed just now, in which in one direction transmission can be taken place, but this was mode. But what could be the different types of communication? Communication could be unitasking. What I mean by unitasking? That between two nodes only one-to-one communication is there. So one type of communication could be unitasking. Another type of communication could be multitasking. And third type of communication could be broadcasting. Or simply, if they can also be taken as one-to-one communication, one-to-many communication, and this is one-to-all. These are three types of communication. In unitasking, a dedicated line is there which connects only two nodes, and communication can be taken between two nodes only. But if we talk about multitasking, it means one is sender and receiver could be more than one. And in broadcasting, sender is one and receiver are all. So radio could be the best example of broadcasting. Now network, we have learned it is interconnection of computer. But if we want to classify the different types of network, then classification can be done on various parameters. This is network, and now if classification point is concerned, then we can classify our network based upon the size of network, the scale of network, size or scale I'll say. Network can also be classified based upon their the topology they are using, they are physical interconnection or logical interconnection between two or more computers. So I will say this is the type of topology they are using. That means how communication is being done between two or more computers, and it can also be done based upon the transmission media they are using. One more classification is there, we will discuss later on if time permits. So I will be starting with the classification of network based upon its size or scale. On this parameter, we can define our network in three different types of category. One is local area network, then wide area network, and last is metropolitan area network. I hope everybody must be aware with local area network. Local area network is the small network where limited number of computers connected with each other for the purpose of communication. Obviously, the size of this network is either in a building or in an office, or that can be covering the entire campus. What could be its different characteristics of this type of network? Number one, number of computers is limited, that means size is limited. The geographical area they are covering is also limited, and this is local to the environment where it is working. Whereas by wide area network we mean that it is covering not only the entire building, the entire city, it may be covering the entire state, covering the entire country, or the entire globe. So there is no limit to wide area network. We are obviously limited to the globe, not beyond the globe, but it is thousands of kilometers away computers can be connected to each other with the help of wide area network. So this is, if I say what is wide area network, then the answer could be, by wide area network we mean that it is group of network or networks, not only computers, but it is group of different local area networks. And between these two type of network, this is metropolitan area network, which is covering the entire city. It is local area network definitely, but it is local area network which is spread throughout the city. For example, cable TV. Now let's discuss what are the different type of topology for networking. The simplest form of topology is ring topology. Before that, it is better to learn what is a star topology. Topology could be bus, or it may be mesh topology, tree topology, etc. So I'll be starting with the star, as it is indicating by its name, where different types of computer are connected to each other in the form of star. So there is something which is known as central switch, and the communication can be done with the help of these central switches. All the computers are connected in the shape of a star, and communication can take place between two or more computers via this central switch. This type of topology is very simplest in nature, because all the computers are connected to central switch only. Simplest in its structure. This is very good in the terms of scaling. Another new node can easily be connected by establishing a single connection with central switches, and this become the part of this network. Now communication can be taken place with any node. Yes, of course, this is the simplest topology, but the basic difficulty in implementing this topology is, if central switches fail, the entire network fails. So how this problem can be eliminated? Obviously, we can establish another type of topology with the name ring topology, where all the nodes are connected to each other in the form of ring. That means if a node is ready to interact with another node, it can interact to another node in the form of ring only. No central switch is there. Problem of central switch is eliminated completely by using ring topology. A can interact to B, B can send this data to C, C can send it to D, and D can again connect it to A. So this is the closed loop. Of course, no central switch is needed, but if I talk about the transmission delay, transmission time, then definitely the transmission delay is directly related to the number of nodes in between. If A is ready to send some information to D, that means it has to cover the entire network. The information is flowing in the entire network, but it was not so in star topology. So of course it is good, but there are few basic drawbacks of it, because the performance is slow. Now, as the size of network increases, definitely delay will definitely be increases, lot of cable is needed. How we can remove this problem? The solution could be with us if all the nodes are directly connected to each other. I am just leaving bus topology in between. I am directly switching to mesh topology deliberately, because we have learned that in star topology delay depends how far the node is. So it would be better if the nodes can interact to each other directly. There is direct connection with every node. If A is ready to send some information to C, if it is ready to send some information to B, or if it is interested to send some information to another node which is very apparently looking very close to this, transmission delay will definitely be same. So efficiency of this type of topology is robust. This is considered to be one of the best type of topology in terms of the reliability of network is concerned. Of course, when we are talking the drawbacks of topology, this topology is also having some drawbacks. The basic drawback of this type of interconnection is that the number of connection is more, so the number of amount of cable needed is also more. Number two, it is very difficult to establish. Number three, if there is any problem in network, then maintenance is also one of the challenging tasks. It is not impossible, but obviously complexity of this type of network is more. And next topology could be bus topology, where a single communication line is being used by a number of nodes. They are connected to the single communication line. Information is being sent, information is being flowed to this network, to this communication media in the form of broadcasted. Like information along with the address of destination is floating here. The node whose address is mentioned along with this message will receive this message, rest will ignore it. So this is the simplest, I will call this could be type of topology, but again it is having some limitations, like failing of this node will not affect the entire network, but failing of this communication line will stop the entire network to work. And next topology, if I say hybrid topology, then it will be better hybrid topology, because when two or more types of topology combines together, it will form hybrid. I am having a network which is following star type of network, and then I am having another network following probably bus topology. And if this node is connected to this node, that means this entire network can access this topology. So I am combining the basic characteristics of two topologies together and getting the advantage of both the topology. We have learned so many topologies, but the basic question arises in our mind is, which topology is better among these topologies? Which one is better? Yeah, if I am going to establish a network of my own, I should go with which topology? The selection of topology never depends upon the choice of this topology. It depends upon my requirement. What are my expectations? Like one topology is expensive, another topology could be more reliable. One topology could be cheaper, but its performance is slow. One topology is good in terms of the delay, but it could not be good in terms of its maintenance. So there are few parameters upon which we can select which topology we should go with. Then this parameter could be number 1, the size of network. Then cost. Third parameter could be how reliable the net topology is, reliability. The selection of topology is also based upon the performance, that means transmission delay. Etc. So this is our choice with which topology we should go with. After discussing the network based upon the topology which we are using, now let's know the classification of network based upon the transmission media. Based upon the transmission media, the network can be divided into two: wired network and wireless network. Obviously, we will take it separately, but let me write its different types. Wired network can also be known as guided network or guided media. The network using guided media, and this is known as unguided media. I am writing the name only, unguided. Wireless communication, we can put microwave communication, satellite communication, etc. We must be aware with them. By wired I mean that two computers are connected to each other with the help of some wires. This could be twisted pair, coaxial cable. They can be connected to each other with the help of fiber optics, etc. And another classification could be whether the type of network is peer-to-peer or following the client-server technology. I hope this is all for now. We will be taking the rest portion in another class. Today we have learned the type of network based upon the size, like it can be categorized in local area network, wide area network, metropolitan area network. Network can be classified as the type of topology they are using. That can be star, that can be bus, that can be ring, or it can be mesh. My simple or one question to you people is, if I know how many connections will be needed with the increase in number of nodes, like in mesh topology, if there are 4 nodes, how many communication connections are needed? And if we increase the number of nodes, how can we calculate the number of connection in mesh topology? My simple question is, there is a formula for knowing the number of connections in mesh topology, which is n into n minus 1 divided by 2 is the number of connection mesh topology. So this is the formula through which we can get the number of connection in mesh topology. By mesh I mean this is the mesh of so many nodes. With this, thank you.